So you all have been finding slope and know that slope is considered a rate of change for a very long time. So now we're going to go ahead and talk about the rate of change for something other than linear functions. So to do this, the average rate of change is still the same thing. The first thing that we're going to do is, it's a formula you're very familiar with. The average rate of change is still the change in y over the change of x, which is f of x2, which is the y value, minus f of x1, again the y values, divided by the change in x values. So the first thing we're going to have to do is find those values. So f of x2 is f of 2, and when you plug that in, that is just 2 to the third power minus times 2, which all equals 2. And the second point that we have, f of x1 is f of negative 2, which is negative 2 to the third power minus 3 times negative 2, which is negative 2. Now I am going to go ahead and put the graph up here, and so we can talk about this a little bit. However, you can do this problem without graphing it. So let's go ahead and put those points in there and talk about what this actually means. So the values that we have are going from negative 2 to our first point right here. And then the second point we have is 2, 2. Now it's the same idea. We are finding the average rate of change between those 2 points. So the average rate of change formula, we're just going to go ahead and subtract those values. So we're just going to use that formula that I have above in blue. x2 is 2. F of x2 is also 2. So that gives us 2 minus f of x1, which is also, in this case, negative 2, all over x2, which was 2, and then I'm subtracting x1, which is negative 2. So that gives us a rate of change of 1. And if we look back at what we know about slope, that's right, up 1 over 1. So this line does have that slope of a positive 1. So the rate of change between those 2 points of this function is 1. Yes, it's very, very similar to slope. The only difference with this can be applied for any function, where when you talk about a slope, the slope of that line is only for that line. All right, so this is a little bit more complicated because we are finding the average rate of change from one value to an unknown value. So if I'm going to go through and label this, my function is 2x squared minus 3x. And what this means is I'm letting x1 equal 1, and my second x value is an unknown, and we're just going to call that x for right now. So what does this actually mean? So what this means is we are starting from 1, which our point there is f of 1 is negative 1. And I want to know at any value x what that rate of change is. So this answer is not going to be a number. It's going to be in terms of x because we don't have a specific number. So if x2 was equal to 2, that line would be up here, and I would want to know what that average rate was. But that's not what I'm looking for exactly. I could also want to know what happens if x2 was equal to 3, which means it would be way up here somewhere, right? What would that average rate of change be? So we're going to do this in terms of x. So what that means is our formula stays the same. It's still f of x2 minus f of x1 all over x2 minus x1. And again, in this case, x2 is just going to be x. So we already have our 1 point. We know that is positive 1, 1. That means that x1 is equal to 1, and f of x1, meaning when you plug that in, what does it equal? It equals y, and that is also equal to -1. So what is f of x2? It just equals the original function, which is 2x squared minus 3x. And we're going to let x2, that's just going to stay as x. So when I plug all of that in, what I get is 2x squared minus 3. I subtract f of x1, and f of x1 is just -1 all over x2. And again, we're just saying, in this case, we're going to let x2 equal the variable x, our second value. And then I go ahead and subtract x1, which is 1. So all of this just equals 2x squared minus 3 plus 1 all over x minus 1, or 2x squared minus 2 all over x minus 1. So if at any point in time I am now asked what is the average rate of change between 1 and any given value, let's say 1 and 3, you just plug that 3 into that piece, and then you'd be left with 2 times 3 squared minus 2 all over 3 minus 1. Or 2 times 9 minus 2 over 2. So I will go ahead and start off with what a secant line is. So a secant line is just any line that can touch the graph and goes through the graph in 2 places. It can be anywhere on the graph that goes through the graph in 2 places. Now this is going to be really important because in calculus we're going to be talking about the tangent line, and the tangent line is going to be a huge deal. So the tangent line is an instantaneous rate of change. So we're going to start and just talk about what happens between a secant line right now, which is between 2 different points. So I want to find the equation of a secant line. So if I'm looking for the equation of a secant line from 1 to 2, this is telling me that x1 is equal to 1 and x2 is equal to 2. So I am looking for the equation of a line that goes through this point here, and I'm just going to use it on the graph. We know that's going to be 1, -1, and my second point is going to be 2, 2. And I want this equation of the secant line. Now, step 1 is to find the rate of change. And the rate of change for that is just 2 minus -1 all over 2 minus 1, or just 3. And then the second thing that we need to do is find the equation of that line. So we are going to go ahead and use our point slope formula, which is y minus y1 times m times x minus x1, and plug those values in. Y stays as y, so that becomes y minus 1 is equal to 3 times x minus 1, which leaves us as y plus 1 is equal to, distribute the 3 to get 3x minus 3, subtract 1 from both sides to give us y is equal to 3x minus 4. So this would be the equation of our secant line.